So in the introduction here, it says that here are the supplies that I'll need. You can see that right there. And for the last project, project 15, you're gonna need a soldering iron and solder. So yeah, okay. All right, let me just read out the list of things that you're gonna need to complete all the projects here. You're gonna need a 9-volt battery, a small light source like a flashlight, conductive material like aluminum foil or copper mesh, colored paper, scissors, an old CD or DVD, tape and glue, a box that you can make holes into, basic tools like a screwdriver, 9-volt battery powered component, any battery powered electronic device with at least one switch or push button that you're willing to hack into will do the job. And then the last thing is a soldering iron and solder, which is only necessary for project 15. Okay, so that's the complete list of things. Looks like I'm gonna have to go do some gathering around the house here to find some of these things. But I do know I have a 9-volt battery right here. But this one is quite old. I'm not entirely sure if it's good or not. We'll give that a shot. Anyways, yeah, I'll find some of these things and then I will start the projects. Let's go. All right, so I took a quick little break there. I had to do some things, you know, life gets in the way. All right, so I'm on the step now where I need to download the IDE on the computer in order to have the software to write the code that goes and get uploaded into the Arduino. So I have downloaded the IDE already. I'm going to connect it to my computer. I'm running a Mac. I have an iMac in front of me here, and I'm just going to connect it because that's the step that it says that I need to take. And then once I connect it, it should power on a green light here. That's what it says. So let's see. Okay, so this is the USB cable here. It has one of those ports that many printers have. I don't know what this port is called. If you know, let me know. But it's like this squarish port. So plug that in here. Okay. And plug my dongle here. These iMacs with the ports in the back. Boom, there it is. There is the green light. It's blinking yellow. Okay, so here I ran the IDE and it basically set itself up. You go on the website and you download the IDE and it ran all of these things. It's installed everything by itself automatically. So once I've plugged it in, I get the green light and the yellow light is blinking. Alright, so I'm reading this now and my yellow light that's already blinking, it shouldn't be blinking. This first project here, this first step here is to upload the program, the software, the program, to get this yellow light to blink. And in this case, it's already blinking. So it was already blinking ever since I plugged it in. So yeah, now I gotta figure out. I'm having an issue right now that it's not able to connect to my Arduino for some reason. Okay. All right, so I had to fix an issue where it wasn't connecting to my board. For some reason, I had to unplug and replug my USB cable on the computer side to get it to connect with this board. And then what I had to do is I had to go into, I should probably screen record this actually. All right, so what I had to do is I was looking down here and my Arduino was not connected. And so what I had to do was I had to unplug and replug the cable from the iMac side. All right, so in order to connect to your board, what you have to do is you got to go into Tools, and then you go to Board, and you may see your board here or not, but if you don't, what you're going to do is just go into Port, and then there was a configuration part here, which disappeared now because I already have it connected. But yeah, you just go into Port and you set that up by going into serial port, and then a menu will pop up. Then you make sure you connect it to USB. All right, and you select Arduino UNO. Okay, and then after that, once it's connected, all of this will look like this. This tool menu will look like this. It changes. Okay, right. So since I have it all connected, mine was blinking yellow earlier. All right. That's because, I don't know, maybe through factory, or maybe this is a return part, but someone already added in the script, the program to make it blink yellow. So what I did was to reset that. I just uploaded this automatic void setup, void loop thing that pops up automatically when you open up the Arduino IDE, and I just clicked this and I uploaded it. So I'll just do that now, just like that. You can see down here it's uploading. Okay, and that's exactly what I did, and now you can see that it doesn't blink. So what it tells me to do here, actually, I'm going to try it now myself since I have it connected, is it tells you to upload the blink program onto just to confirm that your yellow lights are blinking. So I don't want to skip that step because it's a learning opportunity. So I'm going to go into Files, it says, and it tells us to go into Example, and then Basics, and then Blink. Once you click that, what's going to happen is this entire pre-programmed code is already populated. All you need to do is upload it onto your Arduino, and once it's done compiling and uploading, you can see it now is blinking yellow like it was earlier. All right, so that is the first section here, just to run through that to make sure you have your connections, everything is working properly, and that's how the Arduino operates. Really cool. Just doing that little action here while I'm uploading stuff, it kind of helps running through the motions, and it's kind of cool. It's really, I can see how this can be very interesting for DIYers or anybody who's learning how to build stuff from scratch. Just uploading that alone and getting it to blink is, it's kind of like that first hit of candy, and it's addicting, you know. That's pretty cool. Congratulations, you successfully programmed the Arduino to blink its onboard LED. Alright, sometimes your brand new Arduino is already programmed with the blink sketch, so you can't tell if you're truly in control. Oh, step 7. Okay, never mind. I don't think this board was an old board at all. It says sometimes your brand new Arduino is already programmed with the blink sketch. So a program, pre-written code is called a sketch here. That's something to note. You can't tell if you are truly in control. If this is the case, change the delay time by changing the number of the parentheses to 100 and upload the blink sketch again. Now the LED should blink faster. Okay, cool. All right, so on the screen here it says that I can change the LED delay. So the delay is at 1000. What is that? Wait for a second. So that's milliseconds, right? 1000 milliseconds is a second. Is that correct? Yeah, I think so. But anyways, if I delete a 0, oops. If I delete a 0, and if I delete another 0, and then I click this upload button, and let's see. Oh yeah, look at that. It's blinking very fast. Look at this. Blink, 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 blink. All right, that's pretty cool. This is actually really exciting. That's really, I don't know. I know obviously that's very basic, but get the actual motion or the action of doing that and uploading it and seeing a result instantly is very satisfying. Super cool. Super cool. So now it's time to start project 1. Okay, so in project 1 it says that I need it says ingredients. That's cool. Switch, an LED, and a 220 ohm resistor. That's what it says right there. All right. And a 220 ohm resistor seems to be 2 red bands and a brown. Okay. Let's find the switch. The switch should be pretty easy to find. An LED, obviously. Should I go red, green? Let's go with green. I like green. Green LED, right? And I need a switch. A switch. This looks like a switch. There you go. A switch. You see that? Yeah. All right. Got a switch. Oops. Everything is so tiny. I feel like my fingers are too big for these components. And a 220 ohm resistor. 220 ohm resistor. Okay. Oh my gosh. Here, look at this. Oh la la. This is like a whole. It almost looks like DNA. No, not really. Okay, cool how it's all taped up like that. Wow. I mean, like, I'm telling you guys, the packaging on this kit is amazing. I've never seen anything like this. Okay, wow. Oh, it unfolds to all of that. Okay. So 2 reds and 1 brown. 2 reds and 1 brown. 2 red and 1 brown. 2 red and 1 brown. Maybe I'm just colorblind. Maybe it's supposed to be this one here. This is the closest one I could see to it. 1 red, 1 black, 1 brown. No, that's 1 black. Okay, everyone. I'm having difficulties finding this one that they're saying is 220 ohms. Either that's red or orange, but I know that's 2 reddish colors and a brown, but I'm not seeing that on here. There's none with, the only one that has 2 red stripes is this blue one, but this one doesn't indicate that it's blue. So what am I missing here? Okay, why don't I just Google this, because this is the only resistive kit that I have on here, right? The rest is just wires. We got this thing here, breadboard. Yeah, no, that's it. And then the rest doesn't look anything like a resistor. Okay, so let me just quickly Google this. Okay. Based on Google here, it says this blue one is also 220 ohms. So, oddly that there is black in the middle. So yeah, I guess so. Then, I wonder why there's black. You know, the last time I've ever read resistor band colors was in grade 11, and that was a long time ago. So there you go. If you guys want to see that, can you see that? Hopefully you can see that. Yes. There you go. That's what it looks like. Okay, so I'm gonna take one of these blue ones, it says, and we'll go from there. Okay, just pop it out. 220 ohms. It's like a machine gun ammo. Pretty cool. Okay, leave that aside. Anyways, so it says the level of difficulty on this first project is very low. 1 out of 5 bars. It's gonna take about 30 minutes. Okay, why not? 30 minutes is 30 minutes. Okay, discover basic electrical theory, how a breadboard works, the components in series and parallel. Okay. Electricity is a type of energy, much like heat, gravity, or light. Electrical energy flows through conductors like wires. You can convert electrical energy into other forms of energy to do something interesting, like turn on a light or make some noise out of a speaker. The components you might use... Okay, let me just read this and then I'll summarize what we're going to try to do, all right? 1 second, I'll be back. Okay, welcome back, everyone. All right, to summarize chapter 1, it basically gives you an overall, the overall knowledge of how electricity works. If you've never learned anything about electricity, this one is a good primer for a lot of that things, a lot of the things that you're about to do in this with the Arduino. Electricity is made up of voltage, currents, and resistance. Okay, voltage. Here's the little picture that they give you here. Okay, voltage is basically the pressure of electricity that gets pushed through the wires. You can think of it like that. And current is the flow of electricity, which is amperage. Resistance is something that prevents electricity from flowing through, which imagine it as if there was water flowing through a pipe, and if you make the pipe smaller in one end, what happens is the flow after the smaller restriction will be much less, right? The same thing happens in an electric circuit. You have current that flows through the wire, but you have resistors, which are things like this, right? This is a resistor, and this will cause the voltage to be lower. Now, something important to know in this lesson is that every circuit, when it travels from positive or higher potential to negative, which is lower potential, it will consume all of the electricity. That's something you need to put in your head. Okay, now why is that important? That's important because when you have a wire, let's just imagine a long wire with no resistance on it, and here is a battery, right? Let's pretend that this battery is very high, like high output. And if I put a piece of wire with no loads on it, connecting the positive and the negative terminals together, what I essentially did was create a short. And a short is dangerous because there is no load in between. Technically, actually, the load is that piece of wire. And so if you have a high-powered battery and you just put a piece of wire on there, that piece of wire will use up all of the energy because it's acting as a load. Now, that's called a short, all right? And that's why it's very important that when you have a circuit, you're building a circuit, you need to make sure you have a load in between the positive and negative terminal that will use up the electric currents, use up the electricity. Hopefully I'm describing this correctly. But they also say in this lesson here that LEDs like this, okay, LEDs, some people may think that if I just, put the positive and the negative onto, the positive and negative onto this battery, it will just, work. But what a lot of people don't know is LEDs like this, they run off of 5 volts or less. And this is a 9-volt battery. So you'll need something that will reduce the voltage before it reaches this LED, okay? And so that's where a resistor comes in. A resistor is something that can reduce the voltage, take that 9 volt and drop it down to 5 volts in order to feed this LED with 5 volts and work without being burnt out. Now, if I just directly put this onto the battery, what will happen is that this will be very bright for a split second and then it'll burn out. And that's the characteristics of LEDs. They will last forever as long as they have the correct voltage. But if you put in too much voltage, then they just burn up really bright and in a split second they're gone and they're dead forever. So that's why it's very important to know that in an electrical circuit, especially for LEDs, you're going to need a resistor in front of it, okay? You can't just connect it to a 9-volt battery or a 12-volt battery thinking that it will work indefinitely. No, it's not going to work. It will work for a split second, but it needs to make it work the way you want it to work. You need a resistor, okay? That is basically the core lesson of Project 1 here. And in this case, in Project 1, they're going to get us to build a simple circuit on the breadboard using these components and a switch and also the Arduino. But they're not making us use the Arduino in a sense where you're uploading a code. They're just basically getting you to, or getting me anyway in this case, just to sip the 5-volt battery, tap into the 5-volt terminal. That's what they're trying to get us to do as a power source, and then just complete a circuit through there. And that's pretty much it. There's no coding involved. It's just basically tapping into the power source of the Arduino once I plug it in. So in this case, I'll plug it in like this. All right. Now it's powered on. In one of these pins here, there should be a 5-volt pin. And we're going to get the power off of there, build a circuit on the breadboard, and return it back to ground, which is negative, okay? Now, let's do that together here, and as I can explain, I guess I can explain more about what they want us to do here. Hopefully my explanation was good, but I think I'll get better as I go along here, so kind of bear with me because this is my first episode. I'm planning on doing all 15 projects and just record it and share it. And for anybody out there who's maybe also doing it as well, you know, you've got something to follow along with. All right. In this case, this is what they want us to do. All right. So we're going to be tapping into, let's see here, 5-volt and ground. So, okay. So this board is situated this way, all right? And it says that there's a 5-volt pin and it's labeled on this side. Let's just use this black connector as a reference, just right underneath it. And if you look, there is, yep, the 5-volt pin. The 5-volt pin is just the 4th pin down from the black connector here. I don't know if you can see that, but yeah, there's a 5-volt pin there. And what they want us to do is they want us to use a red jumper wire and jump it into the positive of the breadboard, okay? Okay, very interesting. I realized here that the picture of the breadboard, they have it flipped this way. So earlier when I was figuring out which way I should flip this, and I just went with the Arduino logo as like the right way up, it looks like they have it the other way, but nevertheless, doesn't really matter. I'm going to be using, just make sure whatever way you have it connected or stuck on, make sure you follow that red goes to positive and negative, the blue goes to ground, okay? Don't mix that up. And they also suggest in this book that you do follow the color, red for positive and black for negative. That way you don't confuse yourself and short things out. Okay, very important. This is the wire that you want to be using, this one right here. Not these. I'm guessing these are called jumper wires. I'm not entirely sure. But the one that you want is the one with the black and red, and it has like these already pre-installed connectors on there. That's what you want. So let's do that. Okay. So what I'm going to do is I'm going to connect before. One of the things with electricity, okay, is when you are connecting things and you don't know if it works or not, you want to make sure you disable the electricity. It's the same thing as in a house. Like when you're changing a light bulb, right? You want to make sure the switch is off, and if you really want to be extra safe, you turn off the breaker. That completely disconnects the electricity from the circuit. Therefore, like if something happens, if you accidentally touch something, you don't get shocked. And in this case, because this thing is so tiny, you want to make sure you disconnect the power source, which is going to be this USB cable. Completely powers down the board. That way, if you accidentally, like let's say you're trying to connect the ground and the positive, and you accidentally somehow touch these two wires together, like so, you've just essentially created a short, which is really bad for electronic components because that will literally fry your board. So in this case, you want to make sure that when you are connecting stuff and you're especially building a circuit, disconnect the power first, all right? Disconnect the power so it gives you some time to evaluate your circuit to make sure that it actually works. Okay, so I'm going to connect this pin to the 5-volt pin, which is 1, 2. Oh, even better actually. It's actually kind of hard to tell which pin because there's an extra pin here which is blank. So I just noticed that on the side here, it labels a 5-volt pin and the ground pin as well. So go with that. That's a lot easier. That's really great. So the 5-volt pin is right here, and it looks like it sits this way. So I'm going to connect it like so. Okay. Yeah, this pin here has a slightly flattish part, and you want to insert that so that it's mating towards the 5-volt here. Like you want to insert it sideways. You want to insert it that the flat part actually is facing the letters. That way you insert it properly. If you insert it sideways, I think it'll still work, but then what will happen is because it's a little bit bigger on the side, kind of like a flat screwdriver, eventually you'll wear out the terminal quicker if it spreads too far out. So make sure you have it flat connector facing towards the letters here. Okay, so now that I have that connected here, it just wants me to connect it to basically any positive terminal. And in this case, I'm just going to connect it on top here. All right, just connect it in like so. See that? I just have it on the first pin on the positive red. And in this case, breadboard fundamentals, these blue and red, positive and ground, they have a strip, a conductive strip underneath it that runs up and down like this way, okay? And so basically if you put power to any of these holes down the line, it will power that entire strip. Now, the ones that are in between here, they run horizontally, okay? But there's a gap in between. So in the middle here, the circuit breaks. So it only is horizontal this way up to like 5 pins. 5 pins, 5 pins, 5 pins. And then on this side as well, 5 pins, 5 pins, 5 pins. These both sides are not connected to each other whatsoever. They actually have a diagram in the book. Let me just show you that real quick. there it is. Right, what I was just explaining there. The conductive strip for positive and negative, and then the ones in between, they run this way, okay? And that way you can create your own circuit. Okay, so we have positive hooked up, and we want to add a, in this exercise, they want us to light up an LED by creating a complete circuit on here and using the power source from the Arduino and then feeding it back into the ground. So what I'm going to do is, like I mentioned earlier, for an LED to be safely lit, you need to have a resistor that is going to drop the voltage down to 5 volts or less, actually, because since we have a 5-volt source here, we're going to have to add a resistor. And in this case, they want us to add a 220 ohm resistor before the LED. In that case, we will definitely have to use this one, like I was trying to find it earlier. This blue one with 2 reds and 1 brown, and the black. Oh, can you even see that? Okay, and the black in between, I guess, means nothing. And I was confused about this earlier. I had to Google it. So if you have the beige one that they have depicted in the book, then yeah, that's great. Use that one. In my case, I'm going to be using this blue one, and I'm going to just connect it into, I don't know, let's say pin 20. I like an even number. I'm going to stick one end into the positive like so. Okay, and then I'm going to bend the resistor and put it into line 20. When I stick it in, it doesn't feel like it's in, but also I guess it's in. So, okay, try to push it down as deep as you can, I guess, until it bottoms out. So now that I have it connected from positive and into pin 20 like so, the next thing you want to do is you want to connect the anode, and the anode side, anode is positive, cathode is negative, okay? So it says here that on an LED, the shorter leg is the cathode, which is the negative, and the anode is the positive. So the longer leg is the positive. You can see on this LED that there is a longer leg and a, can you see that? Okay, I think so. There's a longer leg and a shorter leg. So we're gonna stick the longer leg into the positive, the red, which if you don't know right now, if this thing was live, power would go through the red wire down this red strip into the resistor that's on the leg that is into the positive, go through the resistor, the voltage will drop through the resistor, and power would go through on this 20 strip right here, strip number 20. And then what I'm going to do is I'm going to stick the LED, the long one, into the 20, and I'll just, the shorter one, I'll just put it into number 19. No. Oh, it looks like it needs a little bit of bending. So, okay, long one into 20, and then, gosh, I don't even know if negative is attached there. Okay, let's just try. No, maybe what I'll do is maybe I'll just bend the LED a little bit, and I'll take the shorter leg and I'll put that into 16. That way the wires are not that close to each other. This picture shows that it goes into the next hole, but for some reason in practice here, one of the shorter leg doesn't seem like it's actually in contact with the terminal inside the breadboard. So I'm thinking I need to bend the leg and get it to go into something else here. Okay, I just have the LED going into 17 now because it seems like it just sits better for me anyway. So I have the long leg going into 20 and then the short leg going into 17. Okay, the positive anode, which is the longer leg, yes, the longer leg, going just after the resistor on the same strip of 20, short leg going to 17, okay? And then we're going to complete the circuit by jumping the negative from 17 into the negative ground of the Arduino, okay? So in that case, you're going to take this black wire now and you're going to put it into 17 or whatever pin that you have your negative side of your LED on, in that same strip. You're going to place it in there. Oh. And then you're just going to attach it to the ground terminal. And in this case, there's 2 ground terminals here. You can see on the board that it's a bigger one. So you can put it on any one of those, it looks like. So I'm going to put the one that's a little bit further, just one after the positive, just so we can be safe. And that's my complete circuit right there. Okay. And with any circuit that you build, you just double check to make sure that you aren't creating a short, okay? Because once you've created a short, that's it. It's fried. It's done. So just double check your circuit, making sure that nothing is touching each other that shouldn't be touching each other. In this case, it looks like I'm good here. So I feel comfortable enough to plug in the USB, and if I've connected everything correctly, this green light should turn on. Ta-da! Yay, success. Success. Okay, so that pretty much is how a circuit works, okay? I also realized that I think the next component here is they want you, the next exercise I would say is they want you to use this component, which is this momentary switch. And this switch acts as any other switch. Once you press it, it disconnects or connects the circuit. Right? It's called a momentary switch. And they want us to wire this into the circuit, so having some sort of control. Technically, a switch, when I'm unplugging and plugging this in, it's kind of acting like a switch. But we want to wire in a switch through our circuit here, and with the same circuit, just to turn on the LEDs. So I will do that now. We're going to go into the second exercise here. Take this off. All right, power down our circuit. And what we're going to do is we're going to wire this switch just before the LED and after the resistor. Because this switch has this weird, this 4-prong bottom, it looks like we're going to have to make it leap the board. And in essence, we're only going to be using 2 of the prongs of the leg. While the other 2 will remain dead on the other side of the breadboard. That's what this diagram is showing me here. You can see that? Yeah, okay. So once you've seen that, if you didn't see that, pause the video, make sure you take a look at that diagram, this picture diagram here, and we'll do that circuit right now. So what we're gonna have to do is we're gonna have to move this resistor, one of the ends that's coming into the breadboard, okay, into the numbered side, okay. This, leave the leg that's in the positive wherever, and just you can reposition. In my case, it just came off anyway, so I'm just going to reposition it to, let's say, number 24. And then I will put the other one into G. 24G. So one into positive and one in 24G. That's what I did. All right. And then next is, I think I have that connected. It's kind of hard to tell. This breadboard is so new, it's kind of hard to put it in and make it feel like you're actually in there. Okay. And it looks like for the switch, how it works is you have to complete the circuit by 2 prongs on the same side. All right, you're using that as the connector. Whereas once you flip it over, you know how there's 4 prongs, the other 2 on the other side will remain dead. So you just want to make sure either 2 is connected on one side and the other 2 is connected on the other half of this breadboard. That way there is no complete circuit. This side is essentially a dead circuit right here. This side here, there's no power going through it. All right, and you kind of want to bridge it there. So what I'll do is with the switch, I will have one leg right at 24F and its other leg at 22F. Right, and once I have it sitting like so, the other end here, you can see that the other end here, this side is already dead, so the 2 legs are sitting there. This is no electricity, no circuit will be going, no electricity will be going through these 2, but these 2 will have power. Okay, and now what I need left is to complete the circuit is to jump this second leg into the LED. And what I'm going to be using for that is one of these tiny jumpers. You can see my circuit here. Pause the video if you can't see it, but it's a complete circuit now. See, the positive 5 volt comes out through this red wire, goes through the red strip, goes into, maybe I'll use an Apple Pencil to show you. So 5 volt comes out from this wire here, goes through this breadboard section, this strip, this red strip, goes into the resistor, jumps over the resistor, heat is being built through here, it drops the voltage, goes down into the switch, and once I press the switch, it will allow electricity to jump over to the second prong of the switch into this red jumper, into the positive of the LED, and then lights up, and then goes down the negative into the negative wire, and then jumps into ground here and completes the circuit. Okay, and that's pretty much this. What they want you to do in here is just basically the same circuit you did earlier, but in this case we're adding a switch to it. So now that I'm confident that I have everything in place, that I haven't created a short whatsoever, I'm going to plug this in and see what happens. Okay, so green on this board tells me we have power, but my LED hasn't lit up yet. If I press the switch, I should get light. There you go. I have light. So this switch here is a momentary switch, so it only turns on when I have it pressed down. Cool. Congratulations. We just finished our first project.